guys, today's video is all about how we can use zinc to protect iron from rusting. The first method we're going to talk about today is something called galvanizing. And we normally galvanize steel, which is an alloy of iron used in many building materials. So when iron reacts with oxygen and water, it rusts to make iron oxide. Now the reason this is a problem is that iron oxide is that orangey red stuff that is really flaky, and that means that the material isn't as strong and as tough as it was before. So what we can do to protect this is we can take our steel bar and we can coat it in a layer of zinc. Now the reason that that works really well is because that layer of zinc can stop any of the oxygen and water getting to the iron beneath it. The second method that we're going to talk about is something called sacrificial protection. And in this, you take your steel bar and instead of coating it entirely with zinc, what you can do is you can just put zinc strips down the length of the bar. Now what's really interesting here is that even though I've got loads of iron that's still exposed on the surface, the steel, or the iron in the steel, won't rust. It won't form iron oxide. And that's really weird. The main reasons behind this are that zinc is more reactive than iron. So because zinc is higher up on the reactivity series, it means that the zinc will react with the oxygen preferentially over the iron. And this means that the iron doesn't rust. Let's check that out in a little bit more detail. The basics are that iron, when it rusts, becomes iron oxide. And we talked about how that was super flaky and a bit of a pain. Zinc, when it reacts with oxygen, forms zinc oxide, which is also a really hard and strong material. So that's really not a problem. So ideally, for my building material, I want the zinc to react with the oxygen over the iron. Now what you might be saying is, so does that mean that the oxygen just gets attracted to the zinc, kind of like it's magnetized there? And no, that's not true at all. It's not like the oxygen can decide where it's going to approach and what it's going to react with. If it's on the surface, then the oxygen may very well react with the iron. If the oxygen does react with the iron, then it will form iron oxide, that horrible stuff that flakes that we don't want. So how does the zinc help with this? Well, what the zinc does is because zinc is more reactive on that reactivity series, even if the iron reacts and forms iron oxide, what it can do is it can displace it and steal the oxygen back to form zinc oxide and iron back again. Zinc being more reactive is absolutely crucial to this method working. You could use other metals that are more reactive than iron, but zinc is the most readily available and the cheapest option. So if we look back at our diagram, what we can see is that all of this surrounding iron is also protected by that way more reactive zinc that's nearby. Now, one of the ways that makes this really cool is if we look back at the example of galvanizing steel. Now, if I've got galvanized steel and it gets scratched, that zinc layer that we talked about gets scratched, what happens then? Now, the answer is that nothing happens because even though the oxygen and water can now reach the surface of the iron, the zinc now protects that steel through sacrificial protection. So because it's nearby, it can still protect the iron that's near it. And that's really cool. So there we go. That's the two main methods for protecting iron from rusting using zinc.